what happens when you start to add up hexagonal numbers. So I hope you guys remember what is hexagonal number. So let's recall that first before we go on to the question itself. Hexagonal number. Okay. So this has to do with 1, then, no, not 1, sorry, 7, then 19, and then, okay, that's a long set of, oh, it's here itself. Oh, there is 1, sorry, my bad. 1, 7, 19, 37, so on and so forth. Okay, these are your hexagonal numbers. Hexagonal means 6. Remember? Hexagon has to do with 6. Okay, like that is take 1, 1 plus 7, 1 plus 7 plus 19, so on and so forth. Which sequence do you get? Okay, so adding hexagonal numbers. So what do we end up with? 1, which is equal to 1. 1 plus 7, which is equal to 8. 1 plus 7 plus 19. So I directly will add what? Oh, I should have changed the color. My bad. Let me redo this. It's easier to look at, 1 plus 7, which is equal to 8. 1 plus 7 plus 19. That will be equal to, this is the 8. We already saw that. 8 plus 19 is 27. Then we have 1 plus 7 plus 19 plus 37. So we know that this is already 27. We don't need to add that again. So this would be what? 7 plus 7 is 1 carry, 64. So what are these numbers? The sequence in this. Yeah, we'll just list it. 1, 8, 27, 64, so on and so forth. So what are this set of numbers? These are, I'll give you guys a clue. Think. What are this? Yes, it's over here itself. These are cube numbers. This is your clue. Cube numbers. Numbers which are obtained by multiplying the same thing 3 times. 3 into 3 into 3, 4 into 4 into 4, 5 into 5 into 5. Those are cube numbers. Can you explain it using a picture of a cube? So they already done it actually. So we have 3 into 3 into, sorry, this is 4 into 4 into 4. Well, we need to do this in exam, so let's try doing it. So I draw hexagonal, not hexagon, sorry, a cube like this, guys. First I draw a line, a bit slanted line. Let me do a bit slanted line, and then this, I'll try to keep it equal. Okay. Actually, initially I just draw a lengthy line. Now what I do is, after drawing this rough, and try to keep it equal. After drawing a rough one, then looking at this length, I pick up a point so that they are equal. Draw a parallel line. This draw parallel. And we have a cube structure. And this also, again, I draw a lengthy line, which is parallel to this. Right? Parallel is wherein they will never meet. All that we will be studying again. If you guys know about parallel, that's good. See, we got a cube. So we have, say, oh my bad, 1, 2, and 3. 1, 2, and 3, 1, 2, and 3. We need to write this in exam now, so I'm showing you how to draw. So that would be your cube. So if you keep doing it, you'll end up with this set of numbers: 1, 8, 27, so on and so forth. If you have a Rubik's cube, if you count the surfaces on the, if you count the faces, right? If you count the small cubes, you'll end up with a certain number, and you also have to imagine there is inside also there are cubes. Then you'll get this set of numbers. So what did we do? First, we considered hexagonal numbers. We added them up. We observed that they are cubes of numbers. What does cube mean? We have a cube. We said to have a cube number if we get it from multiplying a particular number 3 times. Particular natural number 3 times. So 2 into 2 into 2, for example. Actually, it need not be natural number, but anyways, that we'll see in the future. 3 into 3 into 3. 4 into 4 into 4. 10 into 10 into 10. So basically, 1000 is a cube of 10. Right? And pictorially, you just draw whatever I did, in this manner, and put dots, and that is your cube representation. So this is nothing but, we'll just write at the bottom 3 into 3 into 3. Right, guys? So that will have 27 dots.